Alright, giving this a shot. So I'm going to be building a forge, sort of, out of old half-inch plate. I say sort of because it's actually meant to host a crucible and heat that up for smelting metals. So when I say old half-inch plate, there's a plate behind me. I adjust this a little bit so that you guys get a better picture of it. It's been there a while. It's got a lot of surface rust on it, but it is still usable because the thicker metals take a long time to rust through. Now the first step, which I've already done, is figuring out what the size of your forge is. Now the crucible that it's going to be containing is roughly, I think, 6 or 7 inches across, and the insulation, which is flexible ceramic padding, is about a ½ inch across. So that we're going to assume the widest, and that gives us about a 9-inch diameter. If you want everything to fit like a glove, then you would cut your pieces a little over 9 inches wide, but we don't. We need air or space around it for the flame, fire, heat, whatever to get through and heat up the crucible. And we want to make sure there's a lot of space for it to get around and heat everything evenly. So what I've chosen to do is make everything about 1 foot wide. That gives roughly 1 inch of clearance on either side of the crucible, probably a little more when I'm done welding because I'm going to space things out. And that also gives the ability to upend the forge and turn it on its side, pull the insulation out, and use it as a heating area for actually forging metals. I'm going to construct, gonna weld the lid or the bottom on solid, and I'm not going to hinge or weld the lid on at all. Obviously you don't want to weld it on because then you can't get in it. I'm not going to hinge it either, mainly because then, well, 2 reasons. Number one is, then if you want to turn it on its side and use it as a forge, you don't have to worry about the lid flopping all over. Number 2 is, if you are smelting metals and something goes wrong and you want to shut the lid in a hurry, you don't have to worry about the putting too much force in it and the lid tipping it over. The lid will just fall off and you just got to pick it up and put it back on. And similarly, if you open it in a hurry, you don't have to worry about it overbalancing the forge, tipping it over and making a mess and possibly breaking your crucible. The lid will just fall off. So it's kind of a safety thing. It's a little warm out. I will obviously not be cutting or welding in this, but what I'm doing right now is laying it out. Now I had a broad variety of paint pens that I cannot find. And I also had some soapstone, which I also cannot find. In a pinch, a regular pencil will do. And the reason is because the graphite actually fluoresces when you are cutting. So the first step is to figure out your width and your placement. Now, if we measure this whole thing, all the usable material, we get a width of just under 53 inches. Now, tilt that up just a little bit so you can see me too. There we go. So 53 inches means that you should be laying it out in lengths of 12, because that'll give us 48 inches across, and we can do 14 inches tall and use up the plate most efficiently. So you can't see it. I already made a mark at 12 inches here, and I made what's a squaring mark on the bottom. And the way I did that is by taking this here square and finding the flattest areas of the metal and aligning it with those and drawing a line. And what that gives me the ability to do now is finding the original mark I made, aligning the square with the mark I made down there, like so, and lining it up with the mark I made for the width up here. So as long as it's all square, then I draw that line right through my mark. And bam! I have my first 12-inch mark laid out. So now I can use my tape measure, or I can just take the same square and go off of here mark out another 12 inches, and then extend that mark by lining this up with it and extending my line. Yeah. Magnetic plate clamps are really handy for this. I don't have any. But if you run across them for fairly cheap, I highly recommend them. And then finding my second mark, which is here, and doing the same thing. Now you can line the square up at the top or the bottom of your squaring line. It doesn't really matter as long as you hold it flat. And then drawing through your mark. Now I have two pieces. And then that's just going to repeat. Now because it's a pencil and that is steel, it's going to wear down really fast. So what I'm going to do is stop this for now and fast forward to when I have it already laid out. Now freehanding this one, because I need to get the camera close enough so you can see the line. Let's see here. You can see that there's a solid line which I'll be able to follow once the cutting torch hits it. And the beauty about using a cutting torch is if the top isn't square, that doesn't matter. You just measure your length a little longer and you can trim it up when you're all done. So now you can see we have 1, 2, 3, 4 12-inch by 14-inch pieces, and the way I'll cut it is I'll cut down all of these, and then I will cut across the bottom, and they will all fall off one at a time, leaving me with 4 pieces to collect. However, it's really hot out. It's still over 80 degrees, so I'm going to wait a little bit. Plus it'll look cooler when it's darker out before I start cutting. So there's the layout. It's pretty straightforward. Alright, so round 2. I got the torch all set up. This is a fun thing, is my torch is actually only rated to cut a maximum of I think 3/8 of an inch, and this is 1/2 inch plate. Now that extra 1/8 of an inch may not seem like a lot, but if the max is 3/8, you'd think it won't cut 1/2 inch. The trick is if you start with a corner and bring it at an angle like that, say your plate is here, and you start, hold on. So your plate is here, and you bring it in an angle. Once you blow through the corner, it's not a melting process, it's a rapid oxidation process. So it'll actually start cutting all the way through the plate. You have to move a little slow, but it'll work. So I am cutting this outside in the grass, as you can see. I do have a hose set up so that if something does catch fire, I can put it out in a hurry. And I'm forgoing some of the safety equipment that I would normally wear. Bare arms, no hat. I have gloves, and I have these, which look like regular sunglasses. To an extent, I guess they are. But they are actually ANSI rated safety glasses, and when I put them on, you can see they pretty well cover the top of my eyes, which is what's really important. And they are dark enough to allow me to use a cutting torch. So here we go. Now preheating the steel, especially when it's thick, is very important because that allows you to make an easier and smoother cut. And 1/2 inch steel, even if it's been baking out in the sun for a while, it does take a while to preheat. Cool thing is I can see the graphite line clear as a day being lit up by the torch. Now what you're seeing when I press for cutting oxygen is actually the rust burning off the rest of the way. And what you should start seeing here soon is the actual steel heating up. Just like that. So a little tricky getting this cut. Once I get going, it should be just fine. Well, that didn't take long. This is why having a hose on hand is important. Now, you can wet it down ahead of time and that helps a little bit, but this bottom layer of grass is usually so dry that it'll go up anyway. And once it burns a little bit, then it won't burn again. So that's a little bit of cutting. I'll move the camera so you can see the other side and me do a little more cutting, and then we'll go to the assembly. Whew. Not the straightest cut in the world, but it gets the job done. One of the things, not sure how visible I am at this point, not very, when you're cutting through a very thick material, sometimes your torch will wander, so it'll cut a little to the left or cut a little to the right. More noticeably on older material, especially if it's corroded, because it'll hit a piece of already oxidized metal and it won't cut through it, so it'll kind of skew the flame off to one side or another. So that's it for now. Focus doesn't work very well in this light. When I pick up, I'll have 6 pieces of fully cut material, and I'll start tacking and fitting them together. Okay, so it's obviously a different day. As you can see behind me, I have all the pieces. I have one sitting there underneath my gloves. And the rest are down there that are cut. Now, it's my job to fit them together and weld them together. Alright, so that's one piece. Now what I'm going to let's do this here. Now the next goal is to get another corner put on so that I have them basically looking like this, square to the bottom plate. And then once they're square to the bottom plate, I can put the other two corners on the opposite sides and square those off the two that I've just tacked up. It sounds a little convoluted, but it works. Now, one thing I'm sure some of you will note is I'm using my little MIG welder here to do the tacks. I'm going to use a stick welder, which is down there, to do the welding. The MIG welder, well, it's also not rated for 1/2 inch, but the torch wasn't either, and the torch could cut it. But the difference is you can't make this put out more power to penetrate it and give you a proper weld. The torch, because it's a heat-based item that's rapid oxidation and not metal fusion, you can get some little tricks in there that will allow you to cut thicker metal than what it's rated for. You just either have to do things like go slower, start at an angle, stuff like this. This will not reliably weld 1/2 inch. Now you have two more or less square pieces and one square corner. Now for the other two. Alright, now that that's done, I've got 3 sides and a bottom. I'm actually going to weld most of this out with the stick welder right now and then put the last side on. The reason is because I can get inside and do all those inside welds relatively easily with one side open. If I put that last side on, then it's going to be a pain in the butt to contort myself to get in there, and I just won't like it. So now we need to get set up for that. Now you can see I kind of had to rearrange things in order to get the welder plugged in, but it works. I think you guys can still see what it is I'm doing, even if it's a little more cramped than it was before. It's been a while since I fired this thing up, so hopefully it works. Yeah. Guess we'll find out if there's a mouse nest in there real quick. So the first step is to do a couple small welds on the inside to kind of strengthen it, and then do some longer welds on the outside. So what the smaller welds on the inside will do is prevent the plate from pulling out too much when I do the ones on the outside. You'll have that sometimes. Ta-da! So now the next step, go ahead and flip it to where I've got access to the side welds. start welding it up. Now 6011 rod gets a lot of bad press because it's usually thought to be really difficult to deal with, really difficult to weld with. But honestly, the truth is, for this kind of stuff, it's almost perfect. I do have an AC welder, which lends its own interesting brand of challenges. But they are inexpensive to buy, and as long as you take your time and know what you're doing, they get the job done. Now the fun part. Seeing how nasty this welding rod is. And so it goes like that for a long time. But thanks to the wonders of video making magic, you guys can skip that part. Okay, day 3 on making this thing. First day was cutting, second day was mostly welding, and this is going to be the final fit up. I have a couple adjustments to make. I don't know, this should show up fairly well, but if you look here, this side is about a ½ inch longer than this side. And that kind of thing happens sometimes, especially with the more sides you add into an object that you're building. Because depending on how you lay this out, and I laid it out corner to corner, if this piece is a little off and this piece is a little off, it gets magnified by the third piece, and then even more so by the fourth piece. But it's not a huge deal. All I got to do is take the torch, trim this down so that it's flush with the end of the bottom plate, and then have it beveled out this way and fill it in with weld. That's what I'm going to do today. And I'm not going to finish it welding it today because it's already after 7 o'clock and I got to work tomorrow. But I'll get this done and I'll finish it welding it probably tomorrow night or Friday night. Probably tomorrow night. It's Wednesday right, or Tuesday right now. Tomorrow night or Thursday night. And then it'll be done. Got a little bit of cleanup to do here on the side where it looks like someone had welded a pipe on. Not sure what that's all about. And I'll just torch that off. And it'll be done and ready to deliver. And there you have it, folks. A little more welding. Like most things, a little more than I planned on. But we got 2 handles, we've got a lid, we've got a hole for the torch cut, or burner, whatever you want to call it. And it's fully insulated. Inside here, it is unfortunately quite heavy, but the benefit of this is not only is this good for smelting metal, but you turn it on this end here and have the torch on the top, and then now it's a forge because this is thick enough you can hammer on it. And on the inside, I have a little over a 1/2 inch of flexible ceramic insulation, and you can see I welded these little metal pegs here in the corners so that it would stay put to where it needed to stay. And then for the torch here, you just cut a little X shape, and that way it kind of seals up around the torch barrel and you don't lose any heat. But I made sure to cut one side. I made sure to cut one side a little bit shorter than the rest so that the gases had an outlet, and if that's not enough, you can just slide that back a little bit more until it is enough. So there you go. One of the biggest and heaviest forges I've ever made. And this will probably last about 200 years. So lastly, because I did gloss over a couple parts, I added these nice heavy-duty handles on here, which are 3/16 inch by 2 inch angle iron, cut to an angle of about 35 degrees, I believe. Welded top and bottom onto the sides. Not only can these be used to obviously carry it, but because of their proximity to the hole for the burner, technical terms are failing me right now, but because of the proximity to this, which is where we place the torch, you can anchor the torch to this and use these to angle it as well. Handle, simple enough, just a thin piece of flat bar that's angled for easier grasping. And I didn't put anything inside the lid for the purposes of making it kind of slot into place, because my idea was that if you wanted to get the lid off in the hurry, all you had to do was kick it and it would slide off. It's heavy enough that it's not going to slide off by accident. Other than that, there's not a lot else to this. It's pretty simple. It's big and beefy. Everything's out of 1/2 inch steel on the inside. Got plenty of space with a little bit of fire brick down there. Then it would turn into a heavy duty forge. And so that's all.